Hi, so I've just got 2 pages here on the timers that I just need to finish, and it's fairly simple stuff. I'm not too sure why I put this page into the book, because basically I talked about the registers, and you can see from here how the registers are named. But one of the registers we're going to look at is this input compare register, and I'm not going to look at it in this video. I'm just going to mention that basically this is coming up in the lab, revolves around understanding what this pin is doing. And then really it was just a simple little exercise. What I really wanted to do is get you to figure out how to do timer 1 with no pre-scaling and what the code might be. So I wrote some code in here that is incorrect, and you need to fix it. You need to tell me what's wrong with it. And so you should be able to do that by now. This code here is also incorrect. If I want the timer 1 on prescaler 1024, then this line here is not quite correct. And there are a couple of things you need to have a look at there. So in both of these, there's some errors that you need to look at. You need to be quite clear about what you're doing in each one. And then this here, I'm going to say that this is correct. And really, when you want to stop a timer, you have no idea which bits are set. You could read each bit, and then if it is 1, clear it. But the easiest thing to do to stop a timer is just to push zeros into all of those bits. But actually, looking at this, there is a subtle error in this too, which I need you to find. So that's all I really wanted to talk about. This is incorrect, you fix it. Simple little question, like if you were working with timer 0 rather than timer 1, then we would change what? Well, basically, looking at these, you can see pretty clearly, just to remind you that this, for instance, means that we're dealing with timer 1. This here is not, clock select bit 12. It is clock select for timer 1 bit 2. Okay, so this is what this numbering system means, and it's used consistently throughout the microcontroller. So now this is timers. By now you've already possibly pushed some questions on Piazza and come and had some answers. And really, I guess in a way, I just apologize for having to deliver these as pre-recorded sessions, because in a lecture, if you've got a question, you can just pop your hand up and say, hey, Bill, that doesn't make sense. Can you explain it a bit better? And that keeps me on my game, and it means that we can close this feedback loop between me talking and me finding out whether you've got it or not to a very short period of time. So really just remember to send your feedback in, let us know how things are going. It seems that we're going to be in this mode for the rest of the semester, I guess. That's the plan at the moment. And hopefully we can make things work for you. And you'll come out of the course understanding what it means to think like a microcontroller. So cheers. Now, in the next video, I'm going to go on into the lab in detail. I may skip this stuff here until I figure out exactly what the lab is going to look like, because this leads into the lab. And so I may skip this material until I've nailed down what I think the lab will look like and how we're going to get you to do that online. Or you never know, maybe it'll happen in the engineering workshops. Who knows? So I'll pause on this sort of stuff for the moment, and then the next set of lectures will go on after this, and it will be around here, external interrupts, or I might skip into something else, change the order of things for a very careful reason. I've got that. Actually, this is a page you probably want to have a bit of a look at, how we might use a timer, and this is just some general information. Yeah, just for you to sort of peruse how much you measure these sorts of things. So cool. So I'll just drop this here, and have a good week studying this stuff. Cheers.